chapter 2 now. Hooray! It's chapter 2, guys. And this time we're talking about data management. Data, tomato. Now, how do we manage data? Well, we use a bunch of different graphs, a bunch of different charts, and other things like that. Diagrams, maybe, and all that. But first, we're going to learn about the two most basic types of graphs, bar graphs and line graphs. You've probably heard of these. Now, a bar graph is the one that's made out of bars. I know, right? So cool. So a bar graph is used to make comparisons between, well, different things, such as the bar graph down here, which I'm going to talk about later. The different categories for the that you're comparing, for the comparison, are on the bottom axis, which is the bottom line. And the vertical one, well, that's divided into equal parts or intervals. And these intervals are also usually, well, they are numeric, i.e., it's something like 0, 1, 2, 3, 4, or 0, 2, 4, 6, 8, 5, 10, 15, 20. So usually they're also friendly numbers because nobody really makes a bar graph and has 3.3, 6.6, 9.9 increments like that. Now a line graph is used to show changes in the same data set over a period of time. Say rainfall over a few years. Now we're going to use the graphs below and complete each statement. So this one is a what graph? Well, it's made of bars. It has these different categories down here. And these are equal intervals of numbers, 5, 10, 15, 20, 25. Blah. So this is a bar graph. The interval of club numbers is something members. So it's going up by 5s. That's the interval. 5 members. According to the graph, the most popular club is, well, for bar graphs, the best thing about it is that the most popular and the least popular are usually pretty obvious because it's literally the highest and the lowest bar. So the most popular club would be the highest bar because that means that the most people attend it. It doesn't say who hates, well, no, not who, how many people hate which club. It says club members at middle school. So the one with the tallest bar is a computer club. The most popular club is the computer club. We did not have a computer club in our middle school. I mean, one of the French teachers tried to open a cosplay club, but... So we move on. And this one shows Katrina's ballet practice. Over here it's numbers, minutes in equal intervals, but over here it's Monday, Tuesday, Wednesday, Thursday, Friday. And it's all connected by a line, which means that this is a line graph. The interval of time is, well, here's the thing. For bar graphs, for the interval, we look at the vertical axis. For a line graph, the interval of time is actually on the horizontal one. So it's going Monday, Tuesday, Wednesday, Thursday, Friday. It's going day by day. So the interval of time is 1 day. According to the graph, Katrina has no ballet practice on. So if you have no ballet practice, you're obviously going to be practicing for 0 minutes. Now, which one of these is 0? Well, Monday is 30, Tuesday is somewhere between 30 and 40, Wednesday is a little under 30, Thursday that's around 25, and Friday is 0. Therefore, Katrina has no ballet practice on Friday. Yay! Now that we're done that section, okay, guys, you can take a break whenever you want. Again, you can take a break whenever you want. Just pause the video. But right now, we're going to move on to section number 2, interpret line graphs. You can use a line graph to show how quantity changes over time, such as this one. It's Ricky's height change in 5 years. Oh, he had a growth spurt. And after you plot all the points, you just connect them with a line. Now you may be wondering what this little squiggly here is. If there's something like, and then over here it's 30 and then 40, and there's a little squiggly, then that just means that there's a time skip. Well, no, not a time skip, but there's just a skip to the next, obviously not the next interval. There's just a skip. Marie grew pumpkins. The table shows the weight gain in pounds of one pumpkin. Make a line graph to display the data. Use the line graph to solve the problems. So we have Marie's pumpkins. That's the title. Try to center it, but the writing's a little big on here, so. Month and weight. So the month are the time intervals, which means that they go on the horizontal axis. Now 1, 2, 3, 4, 5, 6, 7. One, 2, 3, 4, 5, 6, 7. You usually don't want to start over here because this is always 0. Time is 0, value is 0, everything's 0 here. Weight in pounds. And it goes from half to 9. A good interval would be, 1's actually pretty good because half is just half of the thing. Half of a marking. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And what do we do now? Well, we have to label the axes. So month and weight. Instead of writing in pounds, because you don't have enough space, you could always write brackets and then pounds. Or you could write brackets and then pound symbol, which is LB. So for the first month, we have half a pound, which is around here. For the second month, we have 1 pound, which is around here. For the third month, we have 3 pounds, around, that's a little low, here. For the fourth month, we have 6 pounds, which is around here. For the for the fifth month, oh, it plateaus at the end. We have 8.5, which is around here. And then for the 6th month, we have 9. And 7th month, we also have 9. So the basic thing looks around like this. This is more of a curve. In line graphs, you usually connect them by straight lines, so it looks chunky, I guess. But for the 6th and 7th months, because it flattens out, that's what we call plateauing. A plateau is actually a flat piece of land, so, I mean, I guess it makes sense. But now we're going to move on to some questions. In which month did Marie's pumpkin gain the most weight? How do we know this? Or how do we see this, actually? Well, we see that the month number 3 is the most dramatic. Month number 4 is also pretty good, but month number 3 is a little more dramatic. So it says which month, though, so I would say 3 and 4. Month 3 and 4. how do we see this? Well, if the graph, the line on the line graph is steeper, then it's growing faster, or at least increasing at a faster rate. If it's not as steep, then you're not increasing that much. In which month did the weight of the pumpkin stay the same? How do we see this? Well, I mentioned that it's just flat for month 6 and technically 7, and that's a plateau. That's how we see it. It's a flat line. Please don't make the mistake that this is the same as flatlining. That's done. We're going to move on to histograms. Now, histograms are a little bit more complicated because they're very similar to bar graphs, and you can mix them up, but they're not the same. They both use bars, yes, but the bars in a histogram are for intervals of data instead. There are no gaps between the bars of a histogram, so everything's just clustered together, like they're smooshed. Now here, we can see something of, well, these intervals that they mentioned. Age of hikers, 0 to 10, 11 to 20, 21 to 30, 31 to 40, 41 to 50. So this is when you, well, have too many different ages to actually plot them all separately, because then that would be a little bit inefficient. Number of hikers 20, number of hikers 15, blah blah blah. As we can see here, the column or bar with age 1 to 10 has 20 hikers, age 11 to 20 has 15 hikers, and so on and so on and so on. That's how a histogram works. Now let's make one. Oh, it's still at Deer Creek Park, but this time it's how far the hikers hiked. Now every graph needs a title. Teachers can actually take marks off if you don't have a title, because they're just going to tell you, what am I supposed to be looking at? I don't know what you're talking about. I know, sometimes it seems obvious, but you still have to do it. Now, the axes actually, that's how you pronounce it. And it's spelled like axes, which is kind of weird. But the one with intervals is the one on the horizontal axis. So that's distance in miles. Over here we have number of hikers, which is the vertical. And for number, you could just use the pound sign or the hashtag sign. You may realize that I'm writing, well, sideways, because that's how you label the vertical axis. You just write sideways. Now we're going to decide on an appropriate interval. So the highest number that we have is 50, and the lowest that we have is 10. We could do intervals of 10, but we could also do intervals of 5 if there's enough spaces. 0, 5, 10, 15, 20, 25. There's just enough spaces. So we have 0, 5, 10, 15, 20, 25. This might take a while, so I'm going to skip that, but we're going to talk about this first. So for the distance in miles, well, there's 5 categories, and they're all side by side, so technically you could take up 3 squares each. 1 to 3, 4 to 6. I'm going to skip over this. that we're done, the labeling of the axis, we're going to actually plot the data. So 1 to 3 miles, there's 50 hikers for that. Okay. This is a very haphazard bar, but bear with me because I don't have a ruler. Please use a ruler when you're actually doing this to save, everybody's eyes, including your own. 4 to 6 is 35, so 35 ends here, and then 46 is like this. If you have a nice set of coloring pencils, you might want to color these differently too. 7 to 9 is 25, 25 ends here. 10 to 12 is 10 people, so that ends here. And last category, 13 to 15 has 20, so 20 ends here. Well, that's our histogram. It's a bit messy because there's no ruler involved. So if you want to make a nice looking histogram that everybody can read, use a ruler. What length hike did most hikers take? Well, you look at the tallest column or bar, just like a bar graph. And that would be 1 to 3 miles. How many people hiked 10 to 12 miles? Well, it says over there on the data, but if we're going to read the graph, then we realize that the 10 to 12 column ends at 10 hikers, so 10 hikers hiked 10 to 12 miles. But over here it says people, so you should probably write people instead of hikers. Because hikers could be elephants. They usually aren't. But we're going to move on to line plots. Amazingly enough, these are actually different from line graphs. Students in one 5th grade class recorded how many first cousins each student had. Here are the results. Make one tally in the frequency table for each time a particular number of first cousins occurs. Count and record the number of tallies. Display the data in a line plot, making one X for each tally. So let's do that. 1, so there's 1, 1, another 1, and no more. So that's 1, 2, and that's a tally. But for the frequency, we write the number, just 2. Because in case you haven't noticed, this looks like 11. 2, nobody has 2 first cousins, so that's a 0. The frequency would be 0. 3, 1, 1. 4, 1, 2, 3, 4, 5. 5, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Your country might not tally in this way because some countries have a different method of tallying, but 6, 3, 4. 1, 2, 3, 4. 7, 1, 2, 3. So for the line plot, it looked like this. So for 1 first cousin, there's 2 people. For 2, there's 0, so that you don't put anything. 3, there's 1. 4, there's 5. 5, there's 6. 6, there's 4. And 7, there's 3. So you may be thinking this is kind of like a pictogram. It really is, except each symbol is usually just equal to 1. Is it pictogram or pictochart? Because I've heard both. I'm assuming that both are correct. Now for the next month, the 5th graders kept a record of how many times they called one of their first cousins on the phone. Wow. I don't know why you would do that. Here are the results. So now, we're going to record the results in the line plot below. 1, 2, it goes up to 6, so 3, 4, 5, 6. Now we're just going to tally some. 1, 2, 3, 4 for 1. And then 1, 2, 3, 4, 5, 6, 7 for 2. 1, 2, 3, 4, 5, 6, 7. For 3, there's 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You could do the frequency thing, you could not. It's just a double checking mechanism. For 4, there's 1. 5, there's nothing. And 6, there's... Actually, no, 4, there's 2. 6, there's also 1. But there's 0, too, so 1, 2. Everything's checked off? Yes, it is. Number of calls. 0, there's 2, so we put 2 X's. 1, there's 4, we put 4 X's. This is kind of like a bar graph, except with X's. 2, there's 7, so 1, 2, 3, 4, 5, 6, 7. 3, there's 5, 1, 2, 3, 4, 5. 4, there's 2, 5, there's nothing, and 6, there's 1. That's done. So we're going to use that to answer these two questions. How many students made at least one phone call to a first cousin? So it says at least one. Therefore, we have to count everything except the 2 zeros. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 19 students. Then the next question is, sometimes a gap appears in a line plot because something. Where is the gap in the line plot? What does this tell you? So the gap appears because, well, that tally just isn't there. That's not a frequency that anybody did. Or there was no data collected in that frequency. So where's the gap in this one? Well, 5, because nobody called their cousins 5 times. 5, what does this tell you? Nobody called their cousins 5 times. Well, first cousins. First cousins 5 times. Yay! Now, we move on to a problem-solving strategy. Make a table. A music store kept track of the number of jazz CDs it sold each week. In how many of the weeks did the number of CDs sold range from 31 to 40? Okay, I've been hearing that apparently nowadays some kids don't know what a CD is. Just think of it as a thing. If you don't know what the thing is, just think of it as something else. Just replace it, because this bit isn't exactly relevant since it's asking for the same thing. It's not asking for, oh, there's movie CDs, jazz CDs, how many movie CDs are sold. No. But if you don't know what the thing is, well, just make it variable X. Or substitute it with something else. Number of jazz CDs sold. Week, number, week, number, week, number. Now, what facts do we know? Well, we know the number of jazz CDs sold each week. And we want to find, or we need to find, because the question asks us that, how many weeks did the number of CDs sold range from 31 to 40? So the plan that we're supposed to follow is, well, make a table. We already technically have a table, but let's make a different type of table. It asks for, let's say 11 to 20 CDs, weeks, 21 to 30, 31 to 40, 41 to 50. And now let's do this. Week 1, it's 31 to 40, so week 1 is one of them. Week 2 is also one of those. Week 3 is 29, so it's over here. Week 4 is 30, it's right there still because 21 to 30. Week 5 is 31. Week 6 is 28. Week 7 is 25. Week 8 is 19. I'm surprised. Week 9 is 23. Week 10 is 20. Week 11 is 17. Week 12 is 15. Week 13 is 18. This is the category that I'm referring to right now. Week 14 is 21. Oh, I forgot to cross it out. And week 15 is 23. Now we got to remember what the question is asking us. So it's how many of the weeks did the number of CDs sold range from 31 to 40? So it's asking in how many weeks? Now the range from 31 to 40 is this part. So in 3 weeks, the number of CDs sold was in the range from 31 to 40. Now, is the solution reasonable? It seems reasonable. Does our answer make sense? And what other methods could we use to check our answer? Well, we could redo the question. Does our answer make sense? And if it's reasonable, then it usually makes sense, guys. Reread the problem to make sure that we got our facts straight. A music store kept track of the number of jazz CDs it showed each week. In how many of the weeks did the number of CDs sold range from 31 to 40? Well, we got that right. So everything's, well, fine and dandy. Now we're going to use the make a table strategy to solve these practice problems. A meteorologist records the highest temperature in degrees Fahrenheit, not Celsius, each day. How many days did the highest temperature range from 80 degrees Fahrenheit to 89 degrees Fahrenheit? Well, the lowest is 70 something. So let's go from 70 to 79. It's not exactly a proper looking table, but it works. 80 to 89, which is the one that we want, and 90 to, there's nothing over 100, so. Day 1, it's 90, so 1 is over here. Day 2, it's 86. This time I'm going to use tallies because that works too. It doesn't ask for the specific days, it asks for how many there are. So the next one's 391, that's in that range. 94, that's in that range. 88, it's in this range. 6 is 79, this range. 82, this range. 76, this one. 83, this one. 90, this one. So how many days did the highest temperature range from 80 degrees Fahrenheit to 89 degrees Fahrenheit? 4 days. How many days did the highest temperature range from 70 Fahrenheit to 79 Fahrenheit? Well, we already got that. That's 2 days. And of course, you could take a break anytime you want. Now, we're moving on to section 6, mean. Mean number is actually a thing. But it's not a number that is mean and not nice to you. It's another fancy word for average. If you don't know what an average is, I'm going to tell you right now because it's the same as mean. Mean equals to average equals to sum of terms divided by number of terms. An example of this would be 1 plus 3. So the average of it is 2 because 1 plus 3 equals to 4, and then 1, 3, that's 2 terms. 4 divided by 2 is 2. For another example, it would be 1, 3, and 5. Well, actually, no. Let's do something else. 1, 3, and 8. So that's 3 terms, and then 1 plus 3 plus 8 is 12, and the average of that is, well, 12 divided by 3, which is 4. So, the problem over here is describe the average number of fan letters that singer Johnny Jazz received in 1 week. So the average over here, there's 7 terms, something over 7, and that'd be 17 plus 23 plus 12 plus 15 plus 25 plus 7 plus 13 over 7. Now let's calculate this. This is 112 over 7, which is 16. So the average number of fan letters that he received every day for this 1 week is 16. Now let's find the average or mean of the following numbers: 88, 85, and 91. Well, that's 3 terms, and because they've already kindly put the addition signs there, 88 plus 85 plus 91 equals 2. $264. That is divisible by 3. Oh yeah, fun fact, guys. If you don't know this yet, the sum of the digits of a number, if it's divisible by 3, the sum of the digits, okay, guys, then the number itself is divisible to 3. Now, this would divide into 88 over 1. I kind of wrote it floaty there, but over here it's 255 plus 134 plus 313 over 3 equals to something over 3, but we're gonna work that out. And then that would be 134. Because there's 3 terms for each of these. And here it's, oh wow, they already put the addition signs for us. How nice of them. It's over 3, there's 3 terms. The sum is you can do long division, you could do it on paper, you could do it mentally, as long as it's right. 58. Now, Yolanda went to the library every day after school for 1 week. She borrowed 4 books. Okay, How does she go through them that quickly? Like, I mean, I get it if it's like small books, but like if it's big books, like, well, some of the classics, how do they go through them that quickly? Yolanda went to the library every day after school for 1 week. She borrowed 4 books on Monday, 6 on Tuesday, 2 on Wednesday, 4 on Thursday, and 9 on Friday. What is the mean of the books Yolanda borrowed from the library? I.e., what is the mean for every day? Well, there's 5 days. So divide by 5. We add this up, and we get 25 over 5, which is 5. She borrowed a mean of 5 books per day. And of course, mean has its cousins. But they're not... What are some other bad adjectives? Unfriendly, bully, naughty, detention. It's not that. It's median, mode, and range. Guys, remember, you could stop at any time to take a break. You can use the range, mode, and median to describe the numbers of email messages John sent. So you might be wondering, what is mode, median, and range? Well, range is just smallest number or least number to, not subtract, to largest number. And in this case, the smallest number is 4 and the largest number is 8. So the range would be 4 to 8. You could use the dash sign, but that looks like 4 minus 8. Median is when you order all numbers from least to greatest. Find middle number. In this one, I'm going to order them. So we have 4, 5, 5, 4, 5, 5, 6, 7, 7, 8. Now, we find out which one's in the middle. 6 is in the middle. So the median number of email messages John sent is 6. Now you might be wondering, what if there's 2 numbers? Like, what if there was an extra number here, say 9, and it's 6 and 7? Then you take the average, which would be 6.5. But there isn't a 9 here, so. The mode is the number that you see the most. Over here, it could be 5, because there's 2, or it could be 7, because there's also 2. So the mode would be 5 and 7. If there was an extra 7 or an extra 5, then the mode would be, if it was, say, an extra 5, then the mode would be 5. It's just the most common number that you see. The one with, well, the most frequency. The one with the highest bar in a line plot. Now, over here, we get a different set of numbers and, well, different data actually, because it says number of email messages John received. So the number of messages received in order from least to greatest. This is how you figure out median. Least to greatest, 2, 2, 3, 5, 6, 8, 9. What is the greatest number of messages received? The least number. So the greatest is 9 and the least number is 2. So the range would be 2 to 9. Now there's more questions, including what is a mode? So the mode, as we have seen up here, there's 2 2s. 2 2. but there's only one of each of the other numbers. So the mode would be 2. What is the median? Well, let's go back up. And the middle number is 5. So the median is 5. And that's it. Now we're going to do another problem-solving investigation about extra or missing information. Sometimes there's not enough information that they give you. And that means that there's missing information. Sometimes they give you too much information. That's extra information. Extra information is just information that you don't need to solve the problem. Missing information is information that you need in order to solve the problem and isn't there. The table shows the number of 5th graders who signed up for clubs. How many 5th graders total signed up for a club? So what do we know? Well, we know the number of 5th graders that signed up for clubs. And we're going to assume that these are the only clubs. What do we need to find? The number of 5th graders total that signed up for a club. Is there any information that is not needed? Technically, we don't need the none. Because what we want to add up is, well, these. Not this one. Is there any information that is missing? Well, it'd be really nice if they told us that these were the only clubs, but technically we could still solve the problems with this information. So the 5th graders in the art club, there's 12. 5th graders in the movie club. I think they mean theater or drama. I mean, our school used to have an anime club, but, okay, is it a club where you just watch movies? Sounds fun. Chess club, 9 people. Debate club, 5. Oh, our school's chess club. Oh god, that just reminded me of our school's chess club. Or the one that used to be there. Is it gone now? So we add these up, and we get 29. So 29 kids joined a club. Is the answer reasonable? I mean, yeah. How could we check? Well, we could add up all the numbers in the table and then subtract the people that didn't join a club at all, ever. Now, we're gonna do these practice problems. Solve each problem. If there's extra information, identify it. If there's not enough information, tell what information is needed. The student in Mr. Kelly's class collected donations for a food pantry. How many more pounds of food did Patrick collect than Ryan? Patrick, Ryan, pounds of food collected. Well, we have all the information we need. We don't really have any extra. Technically, we don't really need the first sentence, but, well, there was nothing missing at least. Now, how many more pounds of food did Patrick collect than Ryan? Well, Patrick actually collected less food. So Patrick would collect, technically it's 0, but it's also technically a negative number, which we learned about in chapter, I think 12 of grade 4. We're also going to relearn it, again, somewhere in this chapter, but I'll just put 0 pounds for now. The art club sells 23 paintings and 19 sculptures for a total of $382. How much does a painting cost? We're missing information for this. Because if we want to know how much a painting costs, we need to at least know how much a sculpture costs. Because then we can figure out how much a painting costs. Remember what I said last section? Well, actually, no, last chapter. You can't really have 2 variables unless there is a correlation between these 2 variables that you could work with. And by 2 variables, I mean 2 unknown variables. And in here, we have 2. So, yeah. Not enough info. What is the cost of Sculpture. Now, we have another one. Complete the pattern. 5, 9, 13, 17. Well, this is plus 4, plus 4, plus 4. Okay. We don't really have anything extra, nor do we have anything missing. So let's complete it. What's 17 plus 4? 21, 21 plus 4, 25, and then 25 plus 4, well, 29. Youpee! Now, we're going to move on to the next question. Julie practiced shooting free throws for 200 minutes in 5 days. Okay. How many minutes did she practice shooting free throws each day if she practiced the same number of minutes each day? So we don't have any extra information. And we don't really have anything missing. Because we know how many days she practiced, how many total minutes she practiced, and that she practiced the same number of minutes each day. So it's just number of minutes divided by number of days. 200 divided by 5 is 40. A pizza is cut into 12 slices. How many people can be served? Technically, we are missing information because the question here is how many slices is served to each person. Because in case you haven't noticed, if you just serve one slice of pizza to a person, no, that depends on the slice of the pizza. But if it's like a small slice to one person, and they're like in high school or an adult, unless they're dieting, they're going to be hungry. So how many slices per person? Consuela? I don't really know how to pronounce this name. This isn't a common name. I'll just go with Consuela. Earned $128 this week while working at a grocery store. She earned $45 while babysitting and $30 tutoring. How much more did she earn babysitting than tutoring? There's extra information over here because we don't really need to know what she was doing at the grocery store or about her grocery store expeditions and adventures. What we need to know is how much she earned babysitting and how much she earned tutoring, which we do have. How much more did she earn? Well, 45 minus 30. It's not that complicated. 45 minus 30 is $15 more. Section 9, selecting an appropriate display, i.e. deciding which type of graph out of the so many different types of graphs that you could use is actually good for the information that you have. Songs memorized, number of songs, number of students. Students who are putting on a production of Oliver had to memorize 10 songs. At the end of 1 week, these were the number of songs memorized. Which type of graph would you use to display the data in the table? Well, when we decide, it includes, are there numbers on both axes? Because if one of them doesn't have numbers, then chances are it's probably a bar graph. It might be a line graph though, because numbers, well, months aren't exactly numbers. Is October a number? Not really. It's the 10th month of the year, but do both axes have numbers? We just talked about that. Is the data shown in a frequency interval or in frequency intervals? Well, the ones that have frequency intervals are usually histograms. So we talked about that. Are the two sets of data compared? If it's a comparison, then chances are it's a bar graph. Does the data show a change over time? If it's over time, then, well, chances are it's a line graph. The song data shows equal intervals, and both axes on the graph would have numbers. Now, the one that we know that shows intervals, equal intervals, that isn't, well, time, it's a histogram. And I could draw one right now, but it'd be increasingly wobbly, so I'm not going to do that. Which type of graph would you use to display the data in each problem? Explain why, then make a graph. Well, then make the graph. The following test scores were recorded for a science test in Miss Martin's class. So, are there repeat numbers? No, there's barely any repeats. So that means that it would not be a smart idea to do a line plot, because then the line plot would be very, very long, very, very awkward, and everything would only have one tally. Which means that we will need frequency intervals, because we're not comparing anything, technically. So let's make a histogram. Scores shall be the title. And then the horizontal one. So what would be our intervals? Well, we can do it in 5. Like 76 to 80, 81 to 85, yada, 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 yada. I'm going to label it after. Now that we're done labeling everything, well, technically we still have to label the axis, number of students. I can't really do it down here because I don't have enough space. You should do it on a paper where you can actually have enough space. Now, for 76 to 80, we have 1. Oh, we just have 1. And then 81 to 85, we have... Oh, wait, no, 76 to 80, we have 2. Because 80. And then 81 to 85, we have 1, 2... Yeah, that's it. Still 2. 86 to 90. 1, 2, 3, 4, 5, 6. 6 is up here. And then 91 to 95, it's 1, 2, 3, 4, 5. The 5 is around here. Yay! We made it! Except next time, you should use a ruler. Everybody should use a ruler when they're making graphs. Katie kept a log of the number of sit-ups she did each day from Monday through Friday. Okay, since it's a time interval thing, then a line graph would be the most appropriate. And we're going to do the squiggle down here because the thing starts at, well, 50. 50, 60, 70, 80, 90. And then Monday, Tuesday, Wednesday, Thursday, Friday. So Monday she had 52, which is around here. Tuesday, 75. I recommend you actually get grid paper for this because that's, well, more accurate. Wednesday, 98. Thursday, 80. Friday, 100. So it would look something like this. Now, we're gonna go to the last section of the chapter. Integers and graphing. You can pause whenever you want, remember? Numbers that are less than 0 are called negative numbers. And are written with a negative sign, which is the minus sign, which is also a dash. Numbers greater than 0 are positive numbers. Oh, we're gonna soon get into the addition and subtraction of integers. That's gonna be fun. So on a number line, negative integers will be to the left of 0 and positive integers will be to the right of 0. So negative 5 would be here, positive 3 would be here, positive, say 20 would be somewhere over there, negative 100 will be somewhere over there. Write an integer to represent each situation. Temperature is 17 degrees above 0. Since it's above 0, that means it's more than 0, so it's just 17. You don't add a positive sign, which would be the plus symbol. A diver, well, the diver, is 3 meters below sea level. So if you're below sea level is 0. If you're below 0, then it's a negative. Negative 3 meters, 17 degrees. It could be Celsius or Fahrenheit. It didn't specify. Graph each integer on a number line. Negative 2 would be to the left of 0, and it has a little symbol, so it's here. 9 is somewhere over here. Well, actually, no. Depending on the length, yeah, it's actually somewhere over there. And then negative 4 is over here, to the left of 0. 5 is to the right of 0, and it's a little bit off, so it's around here. Negative 6 is to the left of 0, so it's around here. 1 is to the right of 0, it's here. Positive 1, okay, guys? Alright, guys, so we're going to do these. Write an integer to represent each situation. 23 feet below sea level. What did I just say about below sea level? It's negative. Loss of 18 pounds. If you're losing it, then it's negative. So, profit of $74. Well, profit is a gain, is a type of monetary gain. So, positive. 5 degrees below 0. It's below 0, so negative 5. 14 feet above ground. Above ground. Ground is 0, so 14, positive. Gain of 3 kilograms. You're gaining this time instead of losing, so it's obviously the opposite. Just positive. 10 degrees above 0. It's above 0, so it's positive. Loss of 5 ounces. Negative. That's it for this chapter. See you next time.